A charge Q1 equals 5 microcoulombs lies on the origin of an axis. A second charge Q2 equals 7 microcoulombs lies on the 10 centimeter mark. Determine the net electric field at the 15 centimeter mark. So here's our first charge, and that equals 5 microcoulombs, and this is on the origin. And here, 10 centimeters away, we have our second charge, which equals 7 microcoulombs. And here is the charge that we're looking for, which is 15 away from the origin. Of course, centimeters as well. Okay, so what we want to do is find the charge of the first one to the second one, and then the first one to the third one, and then add them together. So let's pretend for a second that this doesn't exist. We're going to use our equation. E1 equals KQ over R squared. And at this point, we're just going to take all our knowns and plug them in. So that would be E equals K, which is a known of 9 times 10 to the 9th, times Q, which is 5 times 10 to the negative 6. Remember, it's microcoulombs, so you have to do that 10 to the negative 6 conversion. And we're going to put it over 0.15 because we're going from here to here. So really, I said pretend like this doesn't exist. That's not true. Pretend like this doesn't exist. There you go. Because we're going from here to the end, which is 0.15 meters. We have to do that conversion. We can't do it in centimeters. We have to do it in our standard unit of meters. So when you plug that into your calculator, you should get and can't forget your unit. Okay, now we're going to bring this back. And pretend like this doesn't exist. So we're going to do the same procedure that we just did, but instead of going from here to here, we're going from here to here. So you, again, plug in all your knowns to this equation, which would be all over our distance, which is remember, we're doing this in meters, which is our standard unit. And when you plug that into your calculator, you should get newtons over coulombs. Now, because these are both positive, you know, this equation does require vector addition, but because they're both positive, we know that it's all going to go in the positive direction. So we can simply add these together. And don't forget your unit, which is newtons over coulombs.